Happy morning, my dear children. Today we are going to discuss a new lesson, that is unit number 3, P block element 2. The last class we completed the second unit, that is about the P block element 1. That is a carbon family, boron family, etc. We completed. Am I right? Next we are studying the remaining element, nitrogen, chalcogen, halogen, and also inert gases, the remaining elements of P block elements. Here also having some occurrence of elements, physical properties, chemical properties, preparation, uses, and also having some inorganic compound structures. Have to learn one by one, okay? So this lesson having a number of equations, how to take written practice. This lesson only having a many number of equations, okay? So try to more concentration about this lesson, okay? Please all of you take the note, we can be discussed one by one. Dear children, the last lesson we learn about P block element. There is a boron family. Next about the carbon family. Am I right? There's two families over. Next about next periodic classification. That is a third lesson we are learning today. P block element 2. P block element 2, that means nitrogen family, chalcogen, halogen, and having inert gases. Okay. First group is about the group 15, nitrogen group element. We know that one. Our air, am I right? Air having 78% per volume having nitrogen in the earth atmosphere containing dinitrogen. That's a dinitrogen gas. And also it has present in the earth crust as sodium nitrate, potassium nitrate. Next about we have to learn about that phosphorus. Phosphorus is the one of the 11th most abundant element. That is a phosphorus. Here he exists as a phosphate. And some of the other members means group 15, we know that on nitrogen, phosphorus, arsenic, antimony, bismuth. Already we learned it. The remaining members, that is arsenic, antimony, bismuth, these are all present as sulfide. Okay. And next about the physical properties. What are the physical properties of group 15 element? This group except nitrogen. Adesar means phosphorus, arsenic, antimony, bismuth. These are all solid state. Am I right? All solid state except nitrogen. Nitrogen is only a gas. We know the atomic number of nitrogen is 7, phosphorus 15, arsenic 33, antimony 51, and bismuth 83. Here dinitrogen, that is a nitrogen having two isotopes, others phosphorus, arsenic, antimony, bismuth, single isotopes. Here nitrogen means nitrogen 14 and nitrogen 15. Next you have to thorough with that atomic mass. Electronic configuration is a very important electronic configuration. Already we learned that one. Nitrogen, phosphorus electronic configuration, arsenic electronic configuration, antimony electronic configuration, bismuth electronic configuration. Already we thorough it. Next about the atomic radius. and density, melting point, boiling point. How to learn it? Here, one of the preparation of nitrogen. Preparation of nitrogen. Nitrogen, about 78% nitrogens are present in the atmosphere, that is the air. We can be prepared nitrogen from the atmosphere. They have one process that is about that fractional distillation. It is one of the industrial preparation. First, the air is converted into liquefied air. That we are saying liquid air. Okay, how to liquefied the air? How to liquefied? That we are saying liquid air. Next, about the we can be prepared the nitrogen by fractional distillation. Fractional distillation means all of you know that one. Am I right? The small class we learned that, and that is based on one of the refining process. Here, as per the difference in the solubility, this one of the substance are we are separating, we are isolating, is based on the solubility. Here we know that one, the maximum content of air is about that about 78% is dinitrogen, and next one is about that oxygen is about 21%. Here the boiling point of oxygen and the boiling point of nitrogen is entirely different. So we can be easily separate nitrogen, dinitrogen gas from the liquefied air, that is a liquid air. Because the boiling point of nitrogen is low boiling point. I think that about the 77 Kelvin. But in the liquid oxygen, the boiling point is high. As we are comparing dinitrogen, it is high. The boiling point of oxygen is about that 90 Kelvin. Okay. So, by means of the solubility, we can be separate dinitrogen gas from air. That is one process. Next, one of the very important question, very important question. How is nitrogen prepared from sodium acid? Sodium acid. Before that, we have to learn what is the formula of sodium acid. NaN3. What's the formula? Formula of sodium acid. NaN3. NaN3 undergoes thermal decomposition. Thermal means all of you know that one, it is one of the heating. We are applying heating. Decomposition. We get. Here the sodium acid is converted into sodium, and also we get nitrogen gas, dinitrogen gas. And also we have to write the temperature. Don't forget the temperature is very important. Okay. 575 Kelvin. What's the temperature here? 575 Kelvin. You have to balance the equation. The reactant side 3 nitrogen, product side having only 2 nitrogen molecule. So if you are multiplied the reactant side by 2 means the product side also we can be 2 sodium, and also we get 3 nitrogen. Next one. It is also obtained by oxidizing ammonia using bromine water. That is ammonia on treatment with the bromine water. What is the formula of ammonia? NH3. What's the formula of bromine water? Bromine? Br2. So we get the ammonia on reacts with the bromine, we get ammonium bromide. Ammonium bromide. So they are having one of the element is a nitrogen. Nitrogen is separated. Okay. How can you write the equation ammonia NH3 plus bromine gives ammonium NH4Br, ammonium bromide, okay, NH4Br, and also we get dinitrogen. How can you balance the equation? Here, the easiest way, the reactant side having 2 bromine atom, but the product side having only bromine atom. So reactant side 1 bromine molecule, the product side having only bromine atom. Okay. In the case of nitrogen, here also 1, the product side also 1. Hydrogen having 3, the product side having 4. Sorry, nitrogen, the reactant side 3. Product side 3, reactant side 1. So, if you are making 4 means, the product side 4 means, we cannot be balance the equation. Making 5. 5 means nitrogen is also not balanced. We can be converted into 6. The product side 6 means, almost there is a possibility for balance the equation, because here having 6, here having 2, 8. So we can be change it here ammonia 8. Next, about how much bromine is there on the product side 6. So now the equation is balanced. Make it 3. With 3 means the equation is balanced. Okay. Next, one of the important point is, what are the properties of a dinitrogen gas? Listen, all of you. In the air, we have 78% of nitrogen, 21% of oxygen, but nitrogen gas is rather inert. It is not a toxic. Nitrogen gas is not a toxic. Why dinitrogen gas is a inert? Why it is a chemically inert character? Means is it has a largely high bonding energy. Due to high bonding energy is high. Due to high bonding energy of the molecule, what is about the value about that? 225 Carl mole inverse. Otherwise, we can be say 946 kilojoules mole inverse. Why nitrogen gas is rather inert means, why it is a chemically inert means, due to high bonding energy. Don't forget, due to high bonding energy. Dinitrogen contains 14.5% of nitrogen 14 and 0.4% nitrogen 15. The dinitrogen are inert character due to high bonding energy of the molecule. What's the value here? 225 Carl mole inverse. Dinitrogen bond having triple bond that we are comparing to other isoelectronic. Iso means same electronic triple bonded systems such as carbon-carbon triple bond, okay, carbon-oxygen bond triple bond, XCN triple bond, XNC triple bond, etc. Am I right? Carbon cyanide, carbon CN also, okay, triple bond. Nitrogen groups, these groups can act as a donor, electron donor. That means these are the group, not nitrogen. These groups are electron donor, but nitrogen, dinitrogen cannot donor an atom. Okay. Here one of the important point, dinitrogen can form complex with metal. The dinitrogen can form complex with metal. It can be donate an electron to the metal like carbon monoxide. Already we learned about the carbon monoxide. Am I right? So next about the chemical reactions. For the chemical reactions, I am taking 3 metals. Which are the 3 metal means? Lithium, calcium and boron. Lithium metal, calcium metal and also boron. Lithium reacts with the nitrogen under room temperature. Okay, under room temperature, we get lithium nitride. What is the formula here? Li3n, lithium nitride. So how can you balance the equation? The product side, if you are multiplied by 2 means we get 6 lithium. So the reactant side make it 6 lithium. They're having reactant side make it 2 nitrogen. So reaction is balanced. Next, what happens? Nitrogen reacts with calcium and boron. It is not a room temperature, okay? When calcium and boron reacts with the nitrogen, it must be a high temperature, elevated temperature, higher temperature, elevated temperature. Calcium reacts with the nitrogen, that is dinitrogen, red hot. We get calcium nitride, formula Ca3N2, Ca3N2. So 3 calcium here having, so make it 3. Nitrogen also 2 having, make it 2. Equation balanced. Next, boron reacts with nitrogen. B plus N2 gives boron nitride. That's a bright red hot. Okay. So how to balance the equation? 2 nitrogen, make it 2 boron, 2 balanced. Here one of the process. What is a process means? Habeas process. Habeas, H-A-B-E-R-S, Habeas process. What is a process means? Synthesis of ammonia. Don't forget the one-word question. Habeas process means synthesis of ammonia. That means dinitrogen reacts with the hydrogen. We get ammonia. That's a direct reaction, okay? One of the direct reaction. We are having high pressure, optimum temperature. And one more point is, we are using catalyst. One of the important point, catalyst. What is about the catalyst? Previously I told you that. What is about the catalyst? The substance which altered the rate of the reaction. Maybe speed up the reaction, slow up the reaction. There are many types, okay? We have one lesson. That time we can be discussed. Anyhow, the catalyst is one of the substance which may be increase the rate of the reaction and which may be decrease the rate of the reaction. Here the preparation of ammonia, we need nitrogen, hydrogen, and also temperature, pressure. We are using one catalyst that is called as an ion, Fe. Ion acts as a catalyst. We get ammonia. N2 plus H2 gives NH3. How to balance the product side, make it 2. Reactant side, hydrogen, make it 3. Balanced. As per our textbook, here having half N2 plus 3 by 2 H2 gives NH3. Here we are using enthalpy of fusion. Delta HF is equal to minus 46.2 kilojoules mole inverse. Okay. Next. Nitrogen reacts with oxygen at a high temperature. Here we are using the temperature is 3473 Kelvin. We get nitrous oxide. Okay, which oxide? Nitrous oxide, one of the important question. Here, how much percentage of nitrous oxide we get means 4.4% yield we get nitrous oxide by the reaction between nitrogen and oxygen. At the temperature is about 3473 Kelvin, 3473 Kelvin. Don't forget how to balance the equation. What is the formula of nitrous oxide? N2O. Here, how much oxygen is there? The reactant side, 2 oxygen. So the product side also make it 2. So our formula becomes 2N2O. So how much nitrogen is there? 2 into 2, 4. So make it there 2 into 2, 4. Now the equation is balanced. The next question is, what are the uses of nitrogen? What are the uses? The first one use, for the manufacture of ammonia, we are using dinitrogen. Okay. Preparation of nitric acid, we are using nitrogen. What is the formula of nitric acid? NaCnO3. Next, one of the important time is about the calcium cyanamide. There we are learning the organic chemistry. Okay. Calcium cyanamide. So, what are the uses of nitrogen? Manufacture of ammonia, nitric acid, calcium cyanamide. Next one. Then dinitrogen, liquid nitrogen, is used for producing low temperature. That's required in cryosurgery. And also they are used for the biological preservation. Here, what is about the cryosurgery? One of the surgery to use to the applications of intense cold. That means we are destroying the unwanted tissue. Am I right? By destroying some unwanted tissue. That is one of the method. Cryosurgery. Okay. Next. How is ammonia prepared? Preparation of ammonia. How is ammonia prepared? What is the formula of ammonia? NH3. So ammonia prepared means we need one reactant. Which reactant means? Urea. Have you heard about the name? Urea, the first organic compounds prepared. The first organic compound is urea. Am I right? Urea. What is the formula of urea? NH2CO. NH2. NH2CO. NH2. This on hydrolysis. This is urea. On hydrolysis with the water, we get ammonia. Okay. Water having oxygen, urea having carbon monoxide. Here the carbon monoxide combines with the oxygen, we get carbon dioxide. They are having two hydrogen, each will be attached, each NH2 group. So we get NH3. How much NH3? 2 NH3. That is one preparation. How to balance the equation? How much nitrogen you have in the reactant side? 2. So make it product side 2. Now the equation is balanced. Next, another one of the important point. Ammonia can be prepared in another one method by heating of ammonium salt with one of the base. Here, what are base? You are saying sodium hydroxide, NaOH, one of the strong base, am I right? Sodium hydroxide. Base means it contains OH group, am I right? OH group, NaOH. Undergoes dissociation, we get Na++, OH minus ion. This OH minus ions, we are saying base, hydroxyl ion. Okay. So the ammonium salt, one of the ammonium salt means NH4 plus ions, and reacts with the OH, we get here one of the hydrogen combines with this OH to form water molecules. So we get ammonia. We get ammonia. What is the formula? NH3. So how can we balance the equation? Reactant side, make it 2 here, 2 ammonia. Product side, make it 2 ammonia. Now the equation is balanced. What about next one? Ammonium chloride. What happens? Ammonium chloride reacts with calcium oxide. What happens? Ammonium chloride reacts with calcium oxide. What is the formula of ammonium chloride? NH4Cl. This one reacts with the calcium oxide. What's the formula? CaO. Calcium combines with the chlorine to form calcium chloride. What's the formula, dear children? CaCl2. And we get ammonia. It is NH3. This hydrogen combines with oxygen to form water molecules. How can you balance the equation? How much chlorine is there in the product side? Calcium chloride. How much chlorine is there? 2 chlorine. So the reactant side make it 2 ammonium chloride. How much ammonium is there? The reactant side 2. So come to the product side, make it 2 ammonia. Now the equation is balanced. Next one. Ammonia is also prepared by the reaction between magnesium nitride. Magnesium nitride formula Mg3N2. Mg3N2. And also magnesium nitride undergoes hydrolysis with water. Otherwise, we can be say magnesium nitride react with water. We get ammonia. And also magnesium combines with OH to form magnesium hydroxide. What is the formula of magnesium hydroxide? MgOH twice. MgOH twice. So, What is the formula of magnesium nitrate? Mg3N2. So how much Mg is there? Reactant side 3 mg. So make it 3 mg on the product side. So magnesium balanced. How much nitrogen in the reactant side? 1 mole having. So make it product side also 2n. Now nitrogen is balanced. What about the hydrogen? The product side we have 3 into 2 is equal to 6 plus 6 in the ammonia. So 12 we have. So the water molecules were multiplied by 6 means that also balanced. Am I right? So next, the industrial preparation of ammonia we are saying. That is the nitrogen and hydrogen that we are saying. The previously we discussed that nitrogen and hydrogen. We are using one of the catalyst, iron catalyst, and also a small quantity of K2O, potassium oxide, aluminum trioxide. For what purpose means? To increase the rate of the reactions. Okay, increase the rate of the reactions we are using, and also by one of the pressure, that is 750 Kelvin temperature, and atmospheric pressure means 200. In this process, hydrogen required from the water gas, already we learned about the water gas, and nitrogen to form fractional distillation of liquid air. Already we learned that one. Next about the properties. What are the properties of ammonia? One of the important point, ammonia, one of the pungent smelling gas. Ammonia is one of the pungent smelling gas. It is lighter than air. It is readily liquefied at about 9 atmospheric pressure. It boils at minus 38.4 degrees Celsius. The freezing point freezes at minus 77 degrees Celsius. It is highly associated through a strong hydrogen bond. Here having one of the hydrogen bond. Already we learned about the hydrogen bond. That means simply we can learn that hydrogen bond with other element. For example, water, hydrogen fluoride. Okay. This is about the hydrogen bonding. It is highly associated through strong hydrogen bonding. Here about the solubility. Ammonia is easily soluble in water. At 20 degrees Celsius and 760 mm pressure. Ammonia reacts with water at very low temperature to form two soluble hydrate. One is that ammonia with 1 molecules of ammonia with 1 molecules of water, and another one is 2 molecules of ammonia and 2 molecules of water are isolated, are separated. The molecules of ammonia and water are linked by hydrogen bond. Already I told that about the hydrogen bond. Hydrogen bond with other element. Okay. In aqueous solution of ammonia may be hydrated. That means carrying some water molecules. That means ammonia. What is the formula of ammonia? NH3 plus water H2O gives. This is a equilibrium reactions, both forward and backward reaction. One of the H from water will be attached to the ammonia. We get ammonium, that is NH4 plus OH minus ion. Okay. Next we have to write about the dielectric constant of ammonia is high. What's the reason? Means it is making a good ionizing solvent like water. So you have to write ammonia undergoes dissociation to form NH4 plus ions plus NH2 minus ions. Ammonia gives, that's a forward and backward reactions, NH4 plus NH2 ions. So the reactants had to make it 2. Now the equation is balanced. Next you have to write K minus of 50 degrees Celsius is equal to, first you have to write the product side. What is about the product side? Ammonium plus, that is NH4 plus. You have to make it a square bracket. And another one also having NH2 minus ion, make it a square bracket. That is equal to 10 raised to minus 30. This is minus 50 degrees Celsius. Okay, don't forget that, minus 50 degrees Celsius. Next again I am taking 2 molecules of water undergoes dissociation to form 2 molecules of water. We get H3O plus OH minus ion. So we have to write K at 25 degrees Celsius is equal to, you have to write product side H3O plus and OH minus ion, that is equal to 10 raised to minus 14. Next we can be learn chemical properties of ammonia. What are the chemical properties of ammonia? Here, first you have to learn about the action of heat. Ammonia on heating above 500 degrees Celsius, above 500 degrees Celsius, we get nitrogen plus hydrogen. So you have to balance the equation. 2 ammonia, 3 hydrogen. Equation is balanced. Here also we are using one of the catalyst, nickel ion. Okay, nickel is one of the used as a catalyst, and also we are using iron also. Next, ammonia does not burn in air. But anyhow, it burns freely in free oxygen to give yellowish flame, nitrogen and steam. Underline the yellowish flame, okay? Important point, one word question. Ammonia does not burn in air, but anyhow it reacts with the free oxygen to get yellowish flame to give nitrogen and steam. Steam means water molecules. How to balance the equation? How to write the equation? NH3 plus O2 gives N2 plus H2O, because hydrogen combines oxygen, we get water molecules. So 2 nitrogen. First we have to make it 3 oxygen is there. So the products will also make it 6 water molecules. Then 6 hydrogen, 12 hydrogen is there, so make it 4 here. Now the hydrogen is balanced. Next, manufacture of nitric acid. One of the important terms we are using. Manufacture of nitric acid. How the nitric acid can be manufactured? That we are saying Ostwald process. Which process? Ostwald, Ostwalds, Ostwald process. manufacture of nitric oxide. Manufacture of nitric oxide. Ammonia reacts with oxygen, that is NH3 plus O2 gives NO plus water molecules. How can you balance the equation? The reactant side, if you are making 5 oxygen molecule means, so 10 we get the reactants, product side, water molecules, the reactant side 5 means the product side 4NO. Okay, make it 4NO and 6 molecules of water. So that is about that. Oxygen is balanced. Next about nitrogen. Here having 4, so make it 4 here. Equation is balanced. Okay. So anyhow, these are the area we learned today. Today assignment. What is about the today assignment means? Preparation of nitrogen from sodium acide. Preparation of nitrogen from sodium acide. Uses of nitrogen. How is ammonia prepared from urea? Okay. These 3 questions, please write the assignment. Thank you all of you. Thank you.